In the field of electromagnetic compatibility, engineers employ a variety of methods to measure radiated emissions. This video illustrates differences and key advantages with three methods used to measure radiated emissions. They are the conventional sweeping method, the recently developed time domain scan, and the further improved accelerated time domain scan. First, let's look at how emissions are measured with each method. The horizontal, vertical, and depth axes of the graph represent the frequency, power, and time respectively, with time flowing from the front side to the back side. With the sweeping method, emissions are measured at one frequency at a time, starting from the lowest frequency to the highest within the measured range. If you repeat the measurement, there is a time gap between two measurements, making it impossible to capture any emitted noise during this period. Even if by chance the noise is identified, its consideration for the final measurement remains uncertain, given its fluctuating peak over time. Subsequently, the time domain scan method was introduced to address some of the issues associated with the sweeping method. Utilizing fast Fourier transformation, the time domain scan method can measure emissions within a specific frequency range at one time and can also employ the QP detector with a long time constant. Yet with this technique, there are still many areas where emitted noise is not measured. Most recently, an enhancement of the time domain scan, the accelerated time domain scan, has emerged. By employing the accelerated time domain scan, emissions can be measured across a selected frequency range of up to 350 MHz with no gaps, revealing the true behavior of electromagnetic noise. This means that, with this method, engineers can conduct emissions measurements without missing any noise. Now, let's explore how these three methods measure varying noise. The accelerated time domain scan can rapidly and accurately capture the highest peak level of emitted noise, monitoring 100% of the electromagnetic noise. It is highly likely that the time domain scan can identify the peak level next, as the area where noise is left unmeasured is smaller than with the sweeping method. When using the sweeping method, it is uncertain whether this peak level can ever be detected. The accelerated time domain scan allows you to continuously monitor the behavior of emitted noise and obtain highly repeatable results with much less variation. We've presented you with three methods for measuring radiated emissions, demonstrating why the accelerated time domain scan stands out as the superior choice. Now, the next move is yours. Learn how to integrate this technique into your workflow. Reach out to us today and we'll guide you through the process.